Hello everyone, welcome to the Learning Notebook. Today we are continuing our series Computer Fundamentals, and this is Lesson 8. In this lesson, we will learn about the memory hierarchy of computers. You can watch the previous explainers of the series from Computer Fundamentals for Beginners playlist. So without wasting any time, let's get started. All right, here's our game plan for today. We'll start with the concept of memory hierarchy, look at the different levels and how they work, dive into their characteristics, talk about why this is all so important, and finally, wrap up with a quick recap quiz to test your knowledge. Okay, let's jump right into the core concept. You see, when we look at any computer system, we run into a major bottleneck. Our CPU, it operates at lightning-fast speeds, but our storage is, well, comparatively pretty slow. And here's the catch. There is literally no single type of memory out there that gives us maximum speed, massive capacity, and a cheap price tag all at once. So how do we fix it? We organize memory into layers. The golden rule you really need to remember here is this simple trade-off. Faster memory is always going to be expensive, so it comes in a very small size. On the flip side, slower memory is much cheaper, which means we can afford to have a lot more of it. And that brings us to this layered structure right here, the memory hierarchy. This is exactly how we bridge that speed gap. To make this super easy to visualize, I want you to imagine your computer's memory is like a physical workspace, kind of like your own office desk. We're going to take a top-down tour of these 5 levels. We'll start at the very top, where access is basically instantaneous, and work our way down to the bottom, where data gets safely tucked away for the long haul. Ready? Let's check out the first level. Right at the very top, we have registers. Now, if we're using our desk analogy, think of a register as holding a piece of paper directly in your hand while you're reading it. It's right there. Because these registers are physically located inside the CPU itself, they are, without a doubt, the absolute fastest memory available. We're talking mind-blowing fractions of a nanosecond here. They hold the immediate instructions and data the computer is actively crunching at that exact millisecond. But just like you can only hold a couple of papers in your hands at once, registers have an incredibly small storage size. Moving down one step, we hit cache memory. So if registers are the paper in your hand, cache is like keeping a few really important papers right on top of your desk. It sits perfectly right between the CPU and your main memory. Its job is to store frequently used data, so your CPU doesn't have to go searching far to find what it needs. Access is super fast, literally just reaching out and grabbing it from the desk. But because it's so fast, it's pretty expensive to make. That's why your computer only has a small amount of cache. But trust me, having it there makes a massive difference in your overall speed. Next up is main memory, which you probably know best as RAM. Think of RAM as a desk drawer right next to you. Obviously, it's slightly slower to pull open a drawer than it is to grab something already sitting on your desk, right? But that drawer is crucial because it holds all of your current active working projects. RAM is your primary working memory. It stores all the programs you're running at this very moment. It's got a moderate speed, but remember, it is volatile memory. What does that mean? Well, it means when you turn the computer off, that drawer gets completely emptied out. So what happens when we need to save things permanently? That's where secondary memory comes in. This is your hard disk drives, your solid-state drives, and your USB pen drives. Going back to our analogy, secondary memory is like having a huge filing cabinet out in another room. Sure, it takes a little longer to get up, walk over, and dig through to find the file you need, so it's definitely slower than RAM. But it gives you massive storage capacity. And the best part is that it offers permanent storage. All your photos, files, and applications stay right there, even when the power is completely off. Finally, sitting at the very bottom, we have tertiary storage. Think CDs, DVDs, or large cloud backups. To round out our analogy, this is like renting a remote storage unit all the way across town. It is absolutely perfect for archiving huge amounts of data that you almost never need to touch. It offers incredibly massive storage space, but as you can probably guess, it has the absolute slowest access time of the entire bunch. All right, so how do all these levels actually work together? It's all about contrasts. Notice how, as you move from top to bottom, the speed decreases and the cost decreases too. But as you move down, your storage capacity drastically increases. And naturally, because those top layers are the fastest, the access frequency by the CPU is highest at the top and decreases as you go downward. So the CPU is hitting those top layers constantly and only visiting the bottom layers when it absolutely has to. Now, why do we even bother with this tiered structure? Why is it so absolutely crucial? Well, layering memory this way perfectly balances cost and speed. I mean, you definitely wouldn't want to build an entire computer using ultra-expensive registered memory, right? And you couldn't build a fast one if you only used a slow hard drive.
This hierarchy improves your overall CPU performance, it reduces data access time, ensures your data is managed efficiently, and honestly, it just beautifully optimizes the entire system architecture. So, to wrap up the conceptual part of our lesson today, memory hierarchy is simply the structured organization of different memory types. It finds that perfect sweet spot, balancing speed, cost, and storage capacity to give us highly efficient processing. It literally allows your computer's CPU to instantly grab data from the nearest available memory level, which keeps your whole system running as smoothly and swiftly as possible. Okay, now comes the fun part. Let's see how much of this you actually remember. Time for a quick recap quiz. Let's test what we've learned. Here's question 1. Memory hierarchy refers to A. Arrangement of input devices, B. Arrangement of memory types based on speed and cost, C. Arrangement of CPU components, or D. Arrangement of software layers. I'll give you a second to lock in your answer. And the correct answer is B. It is the arrangement of memory types based on speed and cost. Awesome job if you got that one right. Let's move to the next question. Question 2. Out of the options provided here, the fastest memory in the memory hierarchy is A. Hard disk, B. Cache memory, C. RAM, or D. Optical disk. Think about which one sits closest to the CPU from this specific list. Go ahead and make your guess. The correct answer is B. Cache memory. Remember, it sits right there between the CPU and RAM, making it incredibly fast. Let's keep going. Okay, let's try question 3. Which memory has the highest capacity? A. Cache, B. Registers, C. Secondary storage, or D. Main memory, also known as RAM. Think back to the very bottom of that hierarchy chart we looked at. The correct answer is C. Secondary storage. Just like that large filing cabinet in the other room, it holds a massive amount of permanent data. All right, question 4. Let's test that fundamental rule we started the lesson with. Which statement is true? A. Faster memory is cheaper. B. Slower memory is smaller. C. Faster memory is expensive and small. Or D. All memories are the same. Read those carefully and make your choice. The correct answer is C. Faster memory is expensive and small. That specific trade-off is the exact reason why we need a memory hierarchy in the first place. And here is our final question for today. Question 5. When the system boots up, instructions are first loaded into A. Cache, B. RAM, C. Registers, or D. Hard disk. Think about where working programs go when they need to be actively used. The correct answer is B. RAM. Excellent work completing the quiz today. It is so incredibly important to test your knowledge as you learn to really make these concepts stick. Before we go, imagine a future where the cost of memory drops to 0. How might computers change if the memory hierarchy was no longer necessary? So that was it for today's lesson. I hope you found this class useful and learned something new about computers. Don't forget to like, share, and subscribe for upcoming lessons in our Computer Fundamentals series. If you'd like printable PDF notes for each lesson, let me know in the comments section. In the next class, we will study input-output devices and their types. Until then, stay tuned, stay healthy, and happy studying. Thank you for watching, and I'll see you in the next lesson.